This session, we are going to continue from where we stopped last week and dig into some intermediate level SQL. So as the first thing today, we will look at something called aggregate functions available in SQL. These aggregate functions can take a collection of values and as input and return or output a single value. So that's what we mean by aggregation. We give a collection of values and we get one single value as the output. SQL offers 5 built-in aggregate functions: average, minimum, maximum, total, and count. So let's see how we can use each of these 5 aggregate functions. Now first, let's consider an instance where we have this particular simple table. This is for a table persons. We have 3 columns: ID, name, and age. And let's say we have a requirement where we want to find the average age of the persons that are in this table. So we can simply find this using the average aggregate function available in SQL. And this is how we are going to write it. We're going to say select AVG. So that is for average. The average function in MySQL is written as AVG. And since it's a function, we have brackets here. And within the brackets, we have to provide which column we need to take the average. So here we have mentioned it as average age. And the rest is the same as a normal SQL select query from persons table. And when we run this SQL query, we should get the result as something like this. Since we are selecting only the average age, in the output, we will only have one column. And usually it will be named as AVG age, same as the function. And we should get one row with the result, whatever the average value of all the age values in this table. So for this simple example, we should get 21.5 as the result. And let's look at another aggregate function, count, that is useful whenever we want to find the number of records or the count of records. So again, it's very similar to the average function. We are going to write it as select count, and within these brackets, we can provide a column name if you want to count a particular column, or if you want to find all the records, you can just specify all here with a asterisk, this star symbol or the asterisk. And the rest is again similar from person, so whatever the table name. So if we consider our example table, we should get, when we run this query, the result as count 4. So there's only one column and one row. And this count aggregate function, we can have a special keyword if we want to find the count, or if you want to count a value in a particular column, but specifically if we want only the distinct values. For example, let's say we want to find how many distinct age values are there in this person's table. We can specify that condition using a keyword distinct followed by the column name. So select count, distinct age, from persons. And in this case, so let me show you the table that we have. So you can see that there are two persons with age 21 and one with 19 and another one 20 with 25. So that means when we run this count distinct age query, we should get the result as 3 because there are only 3 distinct age values, 21, 19 and 25. And rest of these aggregate functions can be used in a similar manner. If we want to find the sum of a particular column, the summation, we can use some age or whatever the column name from tables. So we should get the result as 86 in this case. Or if we want to find what is the minimum value or the maximum value in a particular column, you can use min and max functions. And if you want, you can actually use other things that we learned last week with these aggregate functions as well. So if, for example, if you want to find the sum of age of all persons who has a age greater than 20, you can specify a where clause where age greater than 20. So this aggregate function only matters between this whatever the select column part. So the rest you can have a normal SQL query, whatever the other things that you can specify where clauses or the other things that we are going to learn. When we use these aggregate functions, you will find that there are situations that we want to apply these aggregate functions to a group of tuples or group of records. For that kind of use cases, we can specify that using a special feature available in SQL known as grouping. And in SQL language, that is written using the group by clause or the group by keyword. So this is how we can use the group by keyword. So we have the normal select query, select columns from whatever the table name. And after that, we can specify this group by clause. And then we can mention from using which column or columns we want to group the result. So let's see an example to get a better idea about this. So let's consider this table where we have certain informations about employees working in different departments. So we have the employee's ID, name, and their salary, as well as the department that they work. And let's say we want to find out the average salary of an employee in each department. So that is where we want to use this group by clause. So this is how we can write it. We're going to say select department and average salary from persons, this particular table, group by department. So what that says is we want to select this department and the average salary, but we want to group this result using the values in the department column. That is this. So when we say group by department, what SQL will do is it will group all the records with a particular common value together. So in this case, you can see there are two records with the department accounting and two records with department sales and a single record with department production. So these two will be grouped together, these two together, and this one together. And the aggregate function, in this case, the average function, will now apply to each of these groups separately. So in this case, the average of sales would be 42,000 plus 40 division 2. So that would be 41,000. And the average for accounting department would be 50 and 40. So that would be 45,000. And for production, since there's only one, that would be 57, the same value. So that is how aggregate functions can be used SQL grouping. The next thing we want to learn is the foreign key constraints. So we have learned about this concept of a foreign key in our relational model lesson. So we know a foreign key is a primary key of another table that we include as a column in another table. And when we say foreign key constraints, that is a certain constraint or a rule that we define on using this SQL to prevent actions that would otherwise violate the relationships between the tables. So what that means is basically when we impose a foreign key constraint that will prevent invalid data from being inserted into that foreign key column. So invalid data means it has to be always a primary key of that particular other table. So if you try to insert a value that does not exist as a primary key in that foreign table, that is considered as an invalid value. So when we impose these foreign key constraints, the database will not allow us to insert that kind of invalid values. So this is how we can impose these foreign key constraints. So we have a keyword for that, foreign key, and within brackets we have to provide the whatever the column name followed by the keyword references and the name of the other table, and again within brackets the primary key column of that foreign table. So this is how we can use that statement in actual SQL create table query. So we have the normal create table query up to this. So let's say we are creating a particular table orders and it has an order ID, date, amount, and it also has this person ID column. And let's assume this person ID refers to the primary key of the person's table that we earlier had as an example. So this is going to be our foreign key. And this is where we impose that foreign key as a constraint. So we specify foreign key person ID. That means this column is a foreign key and it references the person's table and its ID column. So again, this person ID column here is a foreign key referencing the person's table and its primary key ID column. So if you do that when we create the table, and if you later try to insert an invalid value that does not exist in the person's table, you will get an SQL error saying that it is an invalid value and it does not exist in the person's table. And now the most important part of today's lesson is this SQL has a special feature called join operations. These join operations are used to combine rows from two or more tables. based on a relationship available between them. And most of the time that would be a foreign key. And this join operation, we call it as a Cartesian product, which requires that the tuples in the two relations match under certain condition. And this join condition actually specified which tuples in the two relations should match together. So let's take this two tables as an example, the persons table and the orders table that we just discussed under the foreign key constraints. So we have an order ID, date, amount, and a person ID. Person ID here refers to the foreign key of persons table. If we want to join these two tables, we have to write a special join query for that. So we're going to say select all from orders, this particular table, and join persons table, and then another keyword on, followed by the whatever the condition that we want to join these two tables. So in this case, my condition would be orders dot person ID. That means this column equals to persons dot ID column. So what that says is I'm instructing SQL to join the persons table onto this orders table using the condition to match this person ID with the ID column in the persons table. So that's what this on condition means. So when we say that, SQL will select the rows from this orders table, and it will, for each of these rows, it will try to match this order person ID in this persons table using the ID. And if there's a match, it will take this record and join it to the end of this record. So for all of these records, it will try to find a match and join it here. So we should get the result as something like this. So you can see this part is the orders table and this part is the joined persons table wherever it has find a match. So you can see 10 and 10, all of them matches. Note one thing here, that in the orders table, we have 4 records. Persons table has 4 records. And there are 3 records here. In the result, you can see there are 3 records coming from the orders table joined by the whatever the matching ones from here. So you can see this Kevin person is not included here since there was not matching record for orders here. Now there are different types of join operations that we can use depending on how the join happens. The first one would be the inner join, or just sometimes we call it as just join, and that returns the records that have matching values in both tables. So if you look at this diagram, that would be clear. So if you have the left table and the right table, when you use the inner join or the just join, what the result would be is this section or the intersection of them. All the records that have matching values in both tables will be included in the result. And there's a second type called left join or left outer join, and that returns all the records from the left table And if there are matching records from the right table, that would be included as well. And if there are no matching records, the columns will be filled with null values. And the right outer join or right join is the opposite of left join. So it will return all the records from the right table, this one. And if there are matching records from the left table, that would be included in the join. And for any records in the right table where there are no matches, the values will be filled with null. And the fourth join type is the full join or full outer join. And that actually returns all the records from both tables. And if there are matching pairs, they will be combined and others will be there with null values for wherever there are missing values. So that would be something like this. All the data from left table plus all the data from right table. So that is like the union of the two tables. So let's see an example for each of them. The inner join is basically what we have already seen. Even if you say inner join or just join, it will be the same. So we will get, since now when we say something like this, select all from orders, this is considered as the left table, whatever the table that we are selecting from. And whatever the table that we are joining, that is considered as the right table. So in this case, only the records that have a matching in left and right both will be included in the result. So let's see the right join and an example. So when we say select all from orders, right join persons using the same condition. In this case, again, the left table would be this orders, right table would be persons. So in this case, what should happen is all the record from right table should be included. And if there are matching values for this person ID and ID, they will be joined here. Or actually, they are all the values from this one plus it will be joined to this left side. So the result would be something like this. You can see all the values from our right table is included here. And for these records where we have a match 10 and 10, as well as this third record, we have records from the left table. But for these two, Anna and Kevin, there are no matching records in the left table, so they will be filled with null values. And let's see the left join. So again, very much similar, select all from orders. So this is the left table, left join persons. So this is the right table again, same condition. So in this case, what should happen is all the rows from the left table would be included in the result here. And if there are matching records in the person table, they will be included as well. So for this order record with person 20 doesn't have a matching record here. So that will be included with null values. Full outer join, the final type of join type, we have that actually select all the record from the left table as well as the right table. And for any matching records, they will be included. And for others, they will be filled with missing values or null values. So all the values from left table is included here. And for matching records, 10, 12, there are matching records from persons table, so they are included as well. But for 20, there's no matching record, so null values. And the rest of the records from persons table are also included. So 10, 12, 13 and 20 included here. But they don't have matching records from the left table. So these are null values.